Related rates. So we have a question, and this involves an oil tanker. So an oil tanker has an accident and pours oil out at a rate of 150 gallons per minute. The oil spreads onto the water in a circle at a thickness of 1/10 of an inch. Given that 1 cubic feet is equal to 7.5 gallons, find the rate of change of the radius when the radius reaches 500 feet. So the first thing we're going to do is draw a diagram. So let's have a look at the key information. So you have an oil tanker has an accident and the oil pours at a rate of 150 gallons per minute. The oil spreads onto the water in a circle at a thickness of 1/10. So we're going to have a circle and we have our oil tanker, which I'm not very good at drawing, but this spills oil which forms a circle, and our circle is going to be increasing. Now, if we redraw this, because we have a thickness, so here's our circle, there's our radius of our circle, and we have a thickness or a depth of 1/10 of an inch, which is like our height. So we need to find the rate of change of the radius when the radius reaches 500 feet. So we need to list our knowns and unknowns. So what do we know? What do we need to find? So first of all, the rate of change. So 150 gallons per minute is volume. So this is going to be our dV in respect to time. dV dt is 150 gallons per minute. We're told that the depth or the height, so I'm going to say height. The height h is 1/10 of an inch. We're given some information, so I'm just going to write that by here. 1 cubic feet is 7.5 gallons. So this tells me I'm going to have to do some converting, change our units. And then I have the rate of change of the radius, so dr by dt, this is in respect to t. We don't know. And we need to find this when the radius is 500 feet. Now, you'll notice that we have gallons per minute and the radius is in feet. So we need to change our units. So the first thing I'm going to do is change the volume. So I'm going to change the volume. So dV dt, this is 150 gallons. And per means divide. So this is divided by 1 minute. Now I need to change my units into feet. So I still need my minutes, but I'm going to need feet. So I'm going to rewrite 1 cubic foot at the top. And then this is going to be 7.5 gallons. So this will, the gallons will simplify. So I will be left with, if I multiply this out, 150 feet, cubic feet, divided by 7.5, sorry, minutes, which will, that will simplify to 20 cubic feet. So we have 20 cubic feet for our volume. Now our height is in an inch. We have 1/10 of an inch. So we need to change that as well. So let's change the height. So, or the depth. So we have the height is equal to 1/10 of an inch. So, actually, let's write the inch. We could rewrite this as 0.1. I'm just going to keep it the same. So, this is an inch. And we need to change this. Now, this is something we need to know. So, 1 foot is equal to 12 inches. So, this is going to be 1 foot over 12 inches. Now, the inches will cancel out, so we're left with 1 over 120 feet. So let's just rewrite that. So our depth is going to be 1 over 120 feet. So we have the information that we need. So in the correct units. So we're going to go ahead and write down what we need. So the next thing is going to be our equations. What do we know? Volume. So volume, we're looking at a cylinder. So a cylinder, we have a circle, area of a circle times the height. So we have the height here, and the area of the circle is pi r squared. So our volume will be pi r squared h. So we need to rewrite this, and we can substitute in what we know. So we have V is equal to pi. So we don't know R yet. So we're going to rewrite H as 1 over 120. Now, this will be pi r squared divided by 120. Now, because we're doing it in terms of time, I'm going to write the t there. Okay, so next step. Okay, so we have dv dt. So we're going to differentiate the volume. And this time we're using implicit differentiation. So we have dv dt is pi over 120 times, so the derivative is going to be 2r. So this is in terms of t. So this is going to be multiplied by dr dt. So the derivative, we can substitute in what we know for volume. This is going to be 20 cubic feet. Pi divided by 120 times 2. And we know what the radius is going to be. This is going to be 500. And dr by dt we need to find in the question. So we can rearrange. So if we can multiply, so multiplying and rearranging our equation. So we should have 20 is equal to, so we've got 2 times 500, so that's 1,000 pi divided by 120. So dr dt is going to be 120 multiplied by 20 divided by 1,000 pi. And this will be, so dr dt, or the rate of change of the radius in respect to time, 0.7639. And this is feet per minute. So we can say the radius is increasing at the rate of 0.7639 or approximately 0.76 feet per minute when the radius is 500 feet.